Use the substitution x equals tan theta to show that the integral from 0 to 1 of 1 over x plus x squared, all squared, with respect to x, is pi over 8 plus 1/4. So first off, we're going to take our substitution and we're going to differentiate it so we can replace the dx. So dx by d theta, when I differentiate tan, I get sec squared. So therefore dx is equal to sec squared theta d theta. And that is what I'm going to substitute in instead of the dx. Now let's deal with the limits. So when x equals 0, we'll have 0 equals tan theta. And so if I do tan inverse on 0, I find that theta is 0. When x equals 1, I'll do 1 equals tan theta. And when I do tan inverse of 1, I'll get pi over 4. So that's my upper limit. Right, so let's rewrite the integral in the theta world now then. So the upper limit was pi over 4, the lower limit was 0. We've got the 1 on the numerator. On the denominator, we've got 1 plus x squared, so that's 1 plus tan theta squared, or tan squared theta. And all of that is squared. Not forgetting that I'm going to replace the dx as well with sec squared theta, d theta. Right, now let's try and simplify this a little bit. Now I notice I've got a 1 plus tan squared here, and I know that 1 plus tan squared is the same thing as sec squared. So I can replace that with sec squared. So I get 1 over sec squared theta squared times sec squared theta d theta. Now I note that this sec squared on the numerator is going to cancel one of those sec squareds that I've got on the denominator to leave me with just the integral of 1 over sec squared. Now I know that sec squared is the same thing as 1 over cos squared. So this 1 over sec squared can be replaced with just simply a cos squared. Right, in order to integrate cos squared, I know that I need to use the cos double angle to do this. I know that cos 2 theta is the same thing as 2 cos squared theta minus 1. So if we make cos squared the subject here, so add 1 to both sides, and then divide through by 2, we get a half cos 2u plus 1/2 is cos squared. So that's obviously more complicated than the cos squared, but it does make it much easier to integrate. Because the cos in the first term, cos is going to integrate to be sine. So we would have, just get a bit more space here. Oops. So, like I was saying, the cos is going to integrate to be sine. So I'll get 1/2 sine 2 theta, but I'm going to have to divide by 2 because of the reverse chain rule, the 2 on the inside there. So dividing by 2 will actually make the coefficient be 1/4 and not 1/2. So this 1/4 sine 2 theta is me integrating the cos term. Now integrating the half term, the half will just integrate to be 1/2 theta. We now need to look at the limits, which remember pi/4 and 0. So substitute the pi/4 in first, so we get 1/4 of sine of 2 times pi/4 plus 1/2 times pi/4. Now substituting the 0 in, so 1/4 of sine 0 plus 1/2 0. So let's go through this then. Now 2 times pi/4 is pi/2. Sine pi/2 is 1. Times by the quarter is 1/4. Then we have the half of pi/4, which is pi/8. And everything in that second bracket, sine 0 is 0. The 0 there is obviously 0. So therefore this is our final answer. And you can see that does match up with what we needed to show.